In this video, we'll continue our discussion of compound events, but at this point, we're going to flip this page over and we'll talk about mutually exclusive and not mutually exclusive events. So mutually exclusive events are events that cannot occur at the same time. These mutually exclusive events, like an example would be a student taking Math 1 during period 2 and taking Math 2 during period 2 in the same semester. That cannot happen at the same time. You cannot be in two places at once. So those are mutually exclusive events. One student cannot be in both places. So our probability math is the probability of A or B, since there's no overlap, would be the probability of A plus the probability of B. So there's no overlap in our spaces, so we'll just say that we can add the individual probabilities together. And then the probability of A and B, so if they can never happen at the same time, what's the probability of them happening at the same time? Well, if they can never happen at the same time, our probability will equal 0. So mutually exclusive events are ones that cannot occur at the same time. There's no overlap. And not mutually exclusive events, well, simply the opposite. And there is overlap. For example, we could talk about like rolling a die. What's the probability of me rolling a 2 and rolling an even number? Well, there's overlap in there because 2 is an even number. So I could roll a 2 and satisfy the first part, or I could roll a 4 and a 6 to satisfy the first part, but a 2 second part, but a 2 satisfies both, rolling a 2 and rolling an even number. So that's how there's kind of like overlap. So anytime there's overlap, just like when we're doing our conditional probability, our OR is the same as our conditional. Because anytime there's that overlap, we're repeating something, and we have to take out that repetition. So we're going to subtract out the repetition. And when we're talking about not mutually exclusive events with an and statement, it's really just like we kind of have, it's kind of like our two-way table probability where we're looking at the single events. So we just have to identify that probability, and this is more like a thinking skill. And there's no math we do. We just have to think about it and set it up. And these will tend to end up just being a singular fraction. I think if we look at some examples, it will make more sense of what this and statement is. Okay, so a box of chocolates contains 6 milk chocolates and 4 dark chocolates. 2 of the milk chocolates and 3 of the dark chocolates have peanuts inside. You randomly select and eat a chocolate. So is there overlap? Well, I have milk chocolates with peanuts and I have dark chocolates with peanuts. So there's that overlap. So these are not mutually exclusive. Because I can have the two events occur at the same time. I can choose a milk chocolate that doesn't have peanuts, or I could choose a dark chocolate that doesn't have peanuts, or I could choose a chocolate that does have peanuts. So there's that overlap with the peanuts. So what is the probability it is a milk chocolate or has no peanuts? So what's my probability? So I'm looking for probability of milk chocolate or no peanuts. Well, the probability of the milk chocolate is equal to, well, there's 6 milk chocolates and a total of 10. So 6 out of 10. And then the probability of no peanuts. So 2 of the milk chocolates and 3 of the dark chocolates have peanuts. So it's 5 total that has peanuts. And we have 10 chocolates. So we know that there's 5 that don't have peanuts. If 5 have peanuts out of 10, then that means 5 do not have peanuts. And now we have to find the probability of and. So the probability of a milk chocolate and no peanuts, well, if 2 milk chocolates have peanuts, then that means 4 milk chocolates do not have peanuts. So that would be 4 out of 10 milk chocolates do not have peanuts. Now we set up our equation and we solve. We'll add these two and then subtract that one. So we'll do 6 plus 5 minus 4. Which will equal 7 out of 10. So I have a 7 out of 10 chance of picking a milk chocolate or picking something that does not have peanuts in it. Like that. Okay, so what is the probability it is a milk chocolate and has no peanuts inside? Well, that one's pretty straightforward. We just have to think a little bit. So I'm looking for milk chocolates with no peanuts. Well, I have 6 milk chocolates, and 2 of the milk chocolates have peanuts. So that means, so we're looking for probability of milk chocolate and no peanuts. So we said that there are there's 6 milk chocolates total, 2 of which have peanuts. So that's going to tell me that there's 4 milk chocolates without peanuts out of my 10 choices, which equals 2 out of 5. So this is like really just like think it through. So I'm looking for my milk chocolates without peanuts, 6 milk chocolates, 2 have peanuts, therefore 4 do not have peanuts, and I have 10 choices, so 4 out of 10 would be milk chocolates without peanuts. Okay, so number 2, we roll a 6-sided die. What is the probability you roll an even number, and we're going to roll an even number or a 5? Well, these are mutually exclusive because I cannot So if I'm kind of looking at the idea that I'm rolling an even number and I'm rolling a 5, well, these are mutually exclusive events because I cannot roll an even number and a 5 at the same time. So if we're doing our OR statement, we're doing the probability of even or a 5, and then we just add the two together. So that's equal to the probability of even plus the probability of a 5. Well, there's 3 even numbers on the die. Oops, sorry about that. Let you catch up. So we have the probability of rolling an even or a 5 is equal to the probability of rolling an even plus the probability of rolling a 5. And the probability of rolling an even would be our 3 out of 6. So I can roll a 2, a 4, or 6, and that's an even number. Plus the probability of rolling a 5, there's a 1 out of 6 chance. So I would add these together, and I get 4 out of 6, or 2/3. So I have a 3 out of 6 chance, and I'm saying I can roll an even or a 5. And I've satisfied this problem. So there's a 3 out of 6 chance to roll an even, there's a 1 out of 6 chance to roll a 5. So altogether, I have a 4 out of 6 chance of rolling the desired outcome. So now, what is the probability you roll an even number and a 5? Well, I mean, this is like where it's logically impossible. It is impossible to roll a single, like roll one time and get an even number that is a 5, because 5 is not even. So this is just impossible. So therefore, the probability equals 0. That's it. So really, it's like for a lot of these, it's just thinking very logically, slowing down our thought process, and really thinking about the circumstances that are being described. And if we can do that, we tend to be successful in this stuff. So really think about the events that are happening, and then once you've identified what kind of events they are, you can use your equations to help you solve and come to the correct solutions. So thank you very much for watching this video about mutually and non-mutually exclusive events. I hope you have a great rest of your day.